All right, so 6.2, we're going to start looking at the other trig functions, like the tangent of x, cotangent of x. What do their graphs look like? Secant of x and cosecant. And to do that, we're going to start off by just reviewing what the sine and the cosine look like. So I'm going to graph each of those here. So first, the sine. So we know the sine has a period of 2 pi. So let's say pi is about here, and then 2 pi would be about here. It has a max of 1 and a min of -1. And it starts off at the origin. So it's going to hit in the middle on the x-axis, and it's going to finish off there. In between, oops, no, I wanted this to be pi, sorry, and that to be 2 pi. In between 0 and pi, it's going to hit its maximum of 1. And in between pi and 2 pi, it's going to hit its minimum of -1. So about here-ish. So that would be here at pi over 2. And here, that would be 1 pi over 2, 2 pi over 2, 3 pi over 2. All right, so the sine just rises up, hits its max, comes down, hits the min, and finishes up, and it just keeps repeating that process over and over again. Cosine's pretty similar. Same shape, different starting point. So pi is about there, 2 pi is about here. Cosine has its max of 1 also, its min of -1, but cosine starts off at its maximum value. And then it's going to come down through the axis at pi over 2. It's going to hit its min right in between 0 and 2 pi, and it's going to hit its max again at 2 pi, finishing one wave, one cycle, one oscillation. And so in between, it's going to have to hit the axis in between its min and its max. That'll be at 3 pi over 2. So coming down through, bottom out, come up, and max out. And then it just repeats that wave over and over again. All right, so another pi over 2 later, it's going to strike down there. Another pi over 2 later, 3 pi, it's going to bottom out. Over and over again, it's going to repeat it, just like the sine. It's its midpoint here down at pi, so another pi later, about right here, it should come down through again with a midpoint, with a maximum in between, right? So we keep repeating those patterns over and over again. So based on those two, we're going to take a look at the graph of the tangent. So y equals the tangent of x. Tangent is equal to the sine of x divided by the cosine of x. So we should be able to look at the graphs of sine and cosine and try and figure out what the tangent looks like to kind of explain its behavior. So I'm going to put another set of axes in here. And mark off the same units. So pi is about here, 2 pi is about there. Looks a little sketchy. Let's try that again. Pi is about here, 2 pi should be equidistant, maybe about there. And 2 pi. So since sine is in the numerator, anytime sine is 0, tangent is 0, because the 0 will be in the top. 0 divided by anything is 0, well, except 0 divided by 0. We'll make believe. So we know if x is 0, the numerator is 0, denominator is 1, so we're going to get a 0 for this function. And again, the sine is 0 at pi, so there'll be another 0 there. 2 pi, we have a 0, so there'll be another 0 there. So the tangent has to hit at 0, pi, 2 pi, and so on. Now, if cosine is 0, like right here, we have a problem because you can't divide by 0. And so anytime cosine is 0, 3 pi over 2, I have a problem. So I have a problem here at pi over 2 because I'm dividing by 0, and here at 3 pi over 2. What's going to happen there is an asymptote. So there's an asymptote at x equals pi over 2, and same thing here. X equals 3 pi over 2, and at all odd multiples of pi over 2. So the next one will be over here at 5 pi over 2. Can't pass through a vertical asymptote because you're dividing by 0. So that would be x equals 5 pi over 2. All right, so what else happens? If we look in between 0 and pi over 2 here, the sign is increasing from 0 to 1. So my numerator is increasing from 0 to 1. My denominator is decreasing to 0. And we can pick a couple of numbers to check that out. So for example, in between 0 and pi over 2 would be pi over 4. So if we think about pi over 4, actually, let's make a table of numbers for the tangent. So x versus the tangent. We know that at 0, we get a 0. I'm going to skip pi over 6 for a second. I'm going to skip, and I'm going to do pi over 4. Pi over 3 we'll do in a moment. And pi over 2, right, that's where we divided by 0. We had an asymptote, so that does not exist there, dne. At pi over 4, the sine and the cosine are equal, square root of 2 over 2, so I'm going to get a 1 right there. So let's say 1 is about here. So pi over 4 is right in between 0 and pi over 2, so I'm going to have that point. So from this point right here, this graph is rising up, but it cannot touch that axis. That asymptote is just going to get closer. Now, similarly, same thing's going to happen on the other side. On the other side here at negative pi over 2, I'm going to get another 0 in the denominator. So at negative pi over 2, I'm going to have an asymptote. And my claim is this is going to drop down to it. So let's just check to see if that's reasonable. I already know I have the point pi over 4, 1, because sine and cosine are the same there. If we check pi over 6, the sine of pi over 6 is 1/2. The cosine at pi over 6 is square root of 3 over 2. Hopefully you have that committed to memory. The halves divide out, which gives me 1 over the square root of 3. And 1 over the square root of 3 is about 0.6-ish. So pi over 6 is around here-ish. 0.6 is about there. Yeah, so I'm not too bad there. At pi over 3, these switch. The sine of pi over 3 is the square root of 3 over 2. Cosine is 1/2. We divide, the 1/2s divide out. I get the square root of 3, which is about 1.7, I believe. So pi over 6 would be about right here. If that's 1, 1.7 is going to be about here-ish. So I have that point. If I look at points on the other side, the sine is negative over here. Cosine is positive, so I'm going to have a negative over a positive, which is negative. So I should have negative values there. What happens after? What happens after that asymptote? Well, we know we have a 0 at pi. So I want to know what's going on between pi over 2 and pi for each of these functions here. So if we move along a little bit here, after pi over 2 would be 2 pi over 3, and then 3 pi over 4, and then 5 pi over 6, 6 pi over 6, or pi comes next. All right, so at pi, I already established I have a 0 there. And then what happens in between? Well, let's think about 3 pi over 4 for a second. Thinking about the unit circle, this is 1 pi over 4, 2 pi over 4, 3 pi over 4 is over here. Pi over 4 is the line y equals negative x. So I'm going to have the x value is negative, the y value is positive. But otherwise, they're both square root of 2 over 2. So positive square root of 2 over 2 for y, negative square root of 2 over 2 for x. So I'm going to get tangent is -1 there. So 3 pi over 4 is between pi over 2 and pi, right in the middle. So right here. And I get -1, which is down here-ish. So I get that point right there. So what I should find is the tangent has a negative component there, and it goes up positive like that. Now, something interesting to note about tangent, this figure right here appears to be the same as this part right there. So let's think about what the period is for that. So I can see from midpoint here to midpoint, there's a distance of pi. And with the asymptotes, I jump from pi over 2 here to 3 pi over 2, which is also a different distance of pi. So it looks like the period of the tangent is pi, not 2 pi like the sine and the cosine. All right, so that was the tangent graph based on looking at sine and cosine graph and calculating a few numbers. Let's look at it on the calculator for fun. And what do we have? Desmos. I'll just delete some stuff. And then let's see, reset. So just y equals tangent of x. So here's that graph of the tangent. Excuse me. My claim is it has some asymptotes at x equals odd multiples of pi over 2. So pi over 2 right there. But I should see as I look up here that the blue is trying to get close to it, but it never can touch because at pi over 2, we have a 0 in the denominator, right? Remember, tangent is sine over cosine. And if we look again at, say, x equals negative pi over 2, I should see again an asymptote, a vertical asymptote for this graph. And so this basic chunk of the tangent here, disconnected from the other ones, lives between negative pi over 2 and pi over 2, which is a period of pi. And then every pi, it just keeps repeating that same pattern over and over and over and over again. Amplitude. This thing goes up forever. Let's think about why that happens for a second. So this thing doesn't have an amplitude. If I focus on, let's use red here again. Let's focus on this part of the graph here to think about what's going on. So for this part of the graph right here, x is getting close to, getting the value pi over 2. Tangent, remember, is equal to the sine of x divided by the cosine of x. So what's happening with the numerator as x gets close to pi over 2? Well, if we look at the graph of the sine up here, as x gets close to pi over 2, the y value is getting close to 1 up there. So my numerator is going to 1. My denominator, cosine, as x approaches pi over 2 here, the y values are heading towards 0. But they're always positive. So my numerator is about 1. My denominator is getting smaller and smaller and smaller. And if you take 1 over a small number, you get a big number. And the smaller the small number, the bigger the big number. In other words, we're getting a number that's 1 over 0. And in this case, 1 over 0 is positive infinity. So that we can see in the graph, we're going up forever. So there's no maximum here. If we look at the other direction here, let's get a new page to look at that. What's happening? Let's pick a different color. So I have pi over 2, let's put it here. Negative pi over 2 would be equally spaced on the other side. So this is pi over 2. Here we have negative pi over 2. And I just want to confirm, right? We just confirmed that chunk rises forever, does not cross. The side drops forever, but does not cross. So I just want to double check the behavior over here. X gets close to negative pi over 2. A lot of times we abbreviate in math by saying X arrow negative pi over 2. You'll see that sometimes. I want to know what the tangent's doing. So y is the tangent of X, which is the sine of X over the cosine of X. So I don't know, what is the sine doing as X approaches negative pi over 2? So I just want to picture the sine graph here. Remember, the sine rises up, comes down. On the other side, it just does the opposite of that. This is pi right there. This is negative pi, sorry. Negative pi over 2 is right there. And so I get -1 there. So as X heads towards pi over 2, the Y values are heading toward -1. And what else do I know? They are negative there, right? Obviously -1. Cosine, so that's the sine. Cosine's a little bit different, right? Cosine starts off at its peak and then drops down to pi over 2 there and drops down to negative pi over 2, 0 there. So as X approaches negative pi over 2 for the cosine of X, I have the Y value is approaching 0, right? That point right there, I'm heading down through the curve like that. So here I'm going to 0, but I'm positive. So that gives me a negative number divided by a positive number. So essentially here, and then that number is getting closer to 0, which means it's getting smaller. So I have -1 over a small number, small positive number, which is going to give me negative over a positive is a negative big number. And the smaller this gets, the bigger that gets. So what I have is I'm still getting a 1 over 0 here, but it's -1 over 0. And -1 over 0 is getting bigger and bigger and bigger, negative infinity. And so that again is that vertical asymptote behavior. As X approaches a fixed number, Y either increases forever or decreases forever. And that right there is the definition of a vertical asymptote from your previous math class. All right, so that's the cosine. Sorry, not cosine, that's the tangent. The cotangent is just the flip of this. So we get pretty similar behavior, but opposite. So let's look at that graph on a calculator. I don't think we need to go through the full analysis. Let's clean this up a little. And then I want to expand. Let's just go from, how about -3.14 to +6.28, about -pi to 2pi. All right. So that's the tangent there. Let's look at the cotangent, which just flips the tangent, sine and cosine. So we can see we get this opposite behavior happening where the tangent had a 0, that's purple. Let's change some colors here. Let's make the cotangent red. All right. Where the tangent had a 0, since I'm flipping the tangent function, I get a 1 over 0. The cotangent function is going to have an asymptote. And where the tangent had an asymptote, like a 1 over infinity, that becomes a 0 instead. So we can see the opposite behavior here. Let's turn off the tangent to make it a little more visible. So tangent had asymptotes at pi over 2 and -pi over 2, 3pi over 2, and so on. Tangent should have zeros there, right? So just to double check, if I click here, I should see pi over 2. And there's 3pi over 2. Now the asymptotes are where the tangent had zeros. Tangent had zeros at 0 and pi and so on. So if I graph something like x equals pi, I should see that is an asymptote for the cotangent. other thing, since I'm flipping the tangent function, taking the reciprocal, I get behavior happening in opposite directions, right? So notice the cotangent function is always decreasing, but the tangent function is always increasing, right? Like the reciprocal of up is down kind of idea. So cotangent and tangent are very similar. Beautiful pattern, huh? All right, moving on.